All right, Logic fans, what's up? And I'm following. So this is our second video on section 5.8, video 5.8b, and we're continuing our study of identity expansions. And we've noticed rather nicely that we can expand these in a very similar way, where we're imagining RxY instead of identity here, and that really gives us an insight into how to solve these problems. So we just did these two in the previous video. And just like we did with relations, I want to point out to you what happens when we put in the negation sign. So for these particular ones, okay, I'll give you a little bit of a hint, but these look just like the following cases from when we did relations, okay? So this sentence would be just like this sentence expanded, except for the identity sign here. You would treat it the same way. Similarly here, it would look analogous to this particular sentence, okay? So pause now and try each of these on 1, 2, and 3. And actually, you know what? Let's start with the second one, because we actually have the solution from the previous video to when this is just identity. So all I've done is I've switched this to the non-identity, and this was the solution to the identity case. So what do you think happens there? Pause now. Okay, so hopefully you got it right. And again, the analog here is really, really nice. All you have to do is replace every single one of these with a not. So it would ultimately end up looking as follows. So just like this with all the nots in here. And so again, this is this, it's this sentence expanded with one object, or one individual constant, two individual constants, and three individual constants. And you've just got these knots everywhere, okay, just like you would in this case. And if you think about it, it says there exists at least one thing such that it satisfies the following description. It's not identical with anything, including itself. So of course this is going to be a false statement, right? Because it's going to have this in there, right? This can't possibly be true, for example. Okay, it's also got, you know, in the three object, it's got this one and it's got this one. Of course, that can't be true. All right, try this one then. What would this one end up looking like? Pause now. Okay, and hopefully you can see it, right? So we're just going to reverse all of these once again, and here, I'll do it real quick. It'll look like this, just like this. So I've basically just reversed the ands and the ors. So now we want the main connective to be and, which is what we have, okay? And we want the inner connectives to be ors, which is what we have here, okay? All right, let's try another one. I want to show you one just so that you can really see it. Try this one with, and again, its analog would be just like this from relations, okay? And then if we tried, yeah, let's do these two. You should just have a quick look at them so that you feel like you can actually do it all. We'll be thorough here, and so it would end up looking like just like this one would, okay? So let's try the first one first. Try this one where it's for all x, for all y. X is not identical with y. And here's your analog with 1, 2, and 3 individual constants. Pause now. Okay, well now your inner and your outer are both ands, so you're going to have, these are going to be ands, right? On all of them, and it's going to be just like that throughout the whole thing. Let me switch it. So it's going to look, you know, this first one here is going to look like this with the 1, the 2, and the 3 individual constant cases. It's going to look just like this, okay? And then similarly for this one, it's just going to be ors all the way through, okay, on the inner and the outer. So it's just going to be ors all the way through. Okay. That's all interesting, and you should feel like you're fairly confident with how to expand these things. So what we should do is we should take some time to look at perhaps building from all of those previous cases some more sophisticated sentences involving identity and non-identity. Let's try that. For example, okay, let's try these cases. What if I added a negation here? Do you remember what the trick was for how to expand situations like that? It's the exact same. So let's start with this one, okay, because we have the solution. We have the solution to this sentence right here. If I add this negation, what happens? Pause now. Okay, well, in this particular case, right, all you're doing is you're basically taking the expansion of this sentence, right, and then it's the negation of it, right? So it's just, just pretend this negation's not here, expand that whole thing, and since the sentence is negation, it's going to be the negation of that whole expansion. So ultimately, you're going to have something that looks like this, just as an example, okay? And of course, you can go ahead and switch that to, by double negating it to this, okay? And then similarly, all right, for the other cases, for the 2 and 3 object cases, all right, you're going to have, it's not the case that, let's do it this way, this whole thing, okay, this whole thing is getting negated, all right, so it's not the case that this whole thing. Similarly, it's not the case that this whole thing. So let me put that in there. It's going to be not the case that the whole thing. Okay, and so of course you can De Morgan this through, right? So if I De Morgan this through, I'm going to go here and I'm going to go here, and this is going to switch to or. So if I were to do that, I would get something like this. I would get the negation there or the negation here. Okay, and then if you want, you can go further and you can take the De Morgan, this one, inside here, and this is going to become or, and this is going to become not. Okay. And this is going to become not. And similarly with this one, if I take this one inside, this is going to become or, and these are going to become your nots. So it's going to end up looking, you're going to have a construction of this type. And then of course you can double negate all of these, right? Pardon me, we'll take that one out. So you can double negate all these. So this is just going to be A is identical with A is identical with B is identical with A, or B is identical with B. Okay, and similarly, you would end up with the exact same construction here. So A is identical with A, or A is identical with B, or A is identical with C, or B is identical with A, or B is identical with B, or B is identical with C, and so on. Okay, and that's exactly what that's going to end up looking like. And then, of course, you're going to end up with the exact same type of solution for this type of problem. Okay, so for problem number 2 here, you're going to have, just imagine it like this. Okay, so if you expand that and then you put parentheses around the entire expansion and put a negation around it, you're going to end up with a solution. So if you recall, our solution to expanding this particular problem looked as follows, right? So our solutions to this one without the negation on it just looked like this. Okay, this is what it looked like. So if I negate it, right, all I'm doing is I'm saying, oh, you gotta take the negation of, oh, and pardon me, I forgot to switch this back. There we go. It should look like this. And so then we're just taking the negation of it, right? So we're going to be taking the negation of that. Similarly, we're going to take the negation of this entire construction here. And again, you can do all the De Morgans and double negatings to clean it up further if you want. But this is exactly what it ends up looking like. Okay, so it's just picture it without that leading negation, expand it, then take the negation of that entire expansion. Okay, so that's really, really a nice thing. All right, let's try a couple more analogs here. So let's do one where we have that pesky negation symbol in the middle, and you can apply the same techniques we used for doing this when we had, relations. So how would you expand this sentence with 1, 2, and 3 individual constants? Pause now. Okay, so one thing we discussed in the relations videos for how to handle cases like this, right? One thing we saw was that, oh, okay, you know what I can do? I can move this negation either to the left or to the right. Either way, it's going to help you out. I'm going to move it to the right. If I move the negation left, or move the negation right, okay, then I'm going to end up with a really, really interesting construction here. I'll show you what it looks like. But you can move this, and then you end up with a construction like this, right? Okay, and now that you've got that, of course, you can double negate it, and you're just going to end up with something like this. Right? And we can get rid of these other parentheses. All right, so it's going to end up looking just like that. And so this sentence is logically equivalent to this sentence, is the point. So you can just expand this guy, which is a lot easier to look at than this guy. And of course, you already know how to expand this. We've done it several times. It looks as follows. It looks like this, right? Okay, and so this, expanded looks like this, and this is a perfectly adequate expansion of this particular sentence, but notice how much easier it was. So all of these tricks are coming back to play, and hopefully that's giving you a lot of confidence with this material. Okay, let's move on to a much more difficult type of sentence. Let's try something like this. Yeah, this one. Try this one. So with 1, with 2, and with 3. Pause now and give that a shot. Okay, so I'm going to give you a little bit of a walkthrough for this one, all right? But basically you're going to have a sentence like this, and we can do this in the step-by-step method detailed when we studied relations. So everything, let's just do the 2-object case. Everything satisfies this description, okay? So in particular, A is going to satisfy that description, and B is going to satisfy that description. So A satisfies it, and B satisfies it. So it looks like this, okay? And notice, since this was a universally quantified sentence, the main connective is and. Can you finish it from there? Pause now. Okay, so I'm gonna go through it together, but everything satisfies this description, so that's going to mean that A is identical with A, and A is identical with B, right? And I should probably make it super explicit by doing it like this. And then of course we're peeling off this quantifier, so he's gone. Okay, so it's going to be that and this. Right? So you're going to do the exact same thing here, which is going to get you that everything satisfies this description. B is identical. So you're going to get B is identical with A and B is identical with B. Okay? So this is going to be the solution to this particular one. All right? Can you finish off the third and the first one from there? Okay, hopefully you can, and if you're getting some time to pause and really think these through, right? But this is going to be easy. This is just going to mean if FA, then A is identical with A, right? So that case is fairly straightforward. But what happens with the third case? Well, with the third case, you're going to have to do all of this for the object C as well, right? So you're going to have everything satisfies this description. So A satisfies it, and B satisfies it, and C satisfies it. So you're going to have a third case like so, right? Okay, and that's going to be the C case. All right, and then we've got to extend each of these to include for C. So it would ultimately end up looking as follows. So hopefully, yeah, it looks like this. Okay, so you've got the third case for FC, and notice we've got all the C cases, and this is C and C and C here. Okay, let's do another video because I really want to make sure that you see the benefit of doing this for proving that arguments are invalid. So we'll catch you on 5.8C.